Hi, I'm Francisco Rodriguez. I will talk about Geo Data and how much new geographical data we are adding to the Wolfram language and Wolfram Alpha. I work in the Wolfram Research South America office. And one of the things I do, it's all this related to Geo Data. So today I want to review most of what we have added to this field since Mathematica 10 when we started. And then all this geographical data is about what we put in the maps. So what are these map elements? Since version 10 of Mathematica, of Wolfram language, we started adding all these geographics functionality. And in general, we have two main things in the maps. The background, which are tiles, which is a relief plot, outline, and something over the map, which is a graphic primitive that might be a general graphics, like a point, a line, or a geographics primitive, like a geopath, geocircle, etc. And in this case, which I will talk more, it's about the entities. The entities that come from the Wolfram language knowledge base and that are shared with Wolfram Alpha. So the main two functions we have now for accessing all these backgrounds, all these maps, are geographics and geoimage. Geographics has been there for a while. This is a simple call. Then we are going to see more examples. And with geographics, there are many other functions that start using geographics, like geolist plot, geohistogram, dynamic geographics, which is another way to use geographics. And something that is new in this latest release, still tagged as experimental, is the geoimage function. The idea of geoimage is to return only the image itself. Many times when we want to do something with the maps, what we want is the image and start playing, start using image processing tools, etc. So before you needed to do your geographics and then try to extract the stuff from the output, but now we are allowing direct extraction of this. Then something else is that we need data to put in the maps. So there are many ways to access this data. For example, we have the general function entity value, all this way to access for example, the polygon, the position, etc. from the entities. Then we have more specialized functions like GeoNearest and some of these related functions. So that I can do, for example, I want to look up for the nearest city to the 0, position in the latitude, longitude world. And it will give me that entity. For example, this is a city in Ghana. Yes, in Ghana. Or if I want, for example, give me the oceans closer to the South Pole. So I can use also named geopositions and get the 5 oceans starting for the nearest to the South Pole. Oceans and seas in general. Also, there are other functions like geoentities. For example, if I want to search for all the mountains in Antarctica, then I can extract them with geoentities and, for example, do a nice geolist plot for them with the background of the Antarctica. Of course, all these functions, geographics and related functions, have many, many options. I'm not talking about the options in this talk in general, but in the examples you will see them. For example, the projection. The projection in this case is very important. If we project the Antarctica with the regular Mercator projection, we cannot, for example, see the South Pole itself. We need to have the proper projection for each map. We have other functions, for example, travel directions. Travel directions allows you to plan a path between two positions. For example, I could even put two very far away cities like Madrid and Shanghai. And I can have a path computed for traveling from one place to the other using GeoPath, which is one of these more geographics primitives. I can show that in the map. So if I want to go by car from Madrid to Shanghai, I might follow this path. And how much is that in distance? Well, I can query that. It's like 12,000 kilometers. That's a long way. And I might ask how long will it take? Like 6 days. I don't think that's planning any sleeping, so probably it's going to be the double. And then we have another function to access more of this geographical data, which is geoelevation data. Geoelevation data allows me to access, we have in our internal servers, we have data for all the world. So for example, for here, I can request what's the value of the elevation in this place. It's 200 meters. So we are in very low elevation. And also, there is a second parameter in this geoelevation data, which allows you to access different types of elevation. Because it's not the same the elevation from above the sea level than above the ellipsoid of reference of the world. So there is a model of the world, not a sphere, but an ellipsoid. And we can measure also the difference between these two types of elevation. One is called geodetic. The usual one, that is the one that we see in a book, is usually the orthometric. The undulation is the difference between these two types of elevation. And I can also request my distance to the center of the Earth. Also, there is a third parameter that allows you to have different types of return data. So if I want not the data, the values, but a nice region object, which I can play with. I can do computation with all this geometric computation we have now for regions. I can request that in the third argument. And for example, here I'm drawing the Chimborazo volcano, which it's a nice volcano because it has the most, it's the point that is more away from the center of the Earth. So you may think that that point will be the Everest, but that's not true. And we can compute that using the center parameter of elevation data, and indeed is 2 kilometers further than Everest from the center of the Earth, and that's because the form of the Earth, which is not a perfect sphere. And another way to access geographic data, which is new in 11.2, is the GeoJSON import-export. So this is a new addition in the import-export framework that we worked from the geographic side, because we are very interested on having this interface with a standard program. So GeoJSON is a standard format used to interchange geographical data. And now we have the capability to export and import that. For example, I can export an empty map, and the only thing that we are exporting in that case is the bounding box. So at least we are showing the bounding box, which is part of the GeoJSON standard. But I can also, for example, export a polygon, like for example the polygon of Madagascar within a geographics. That's going to be a 100 kilobytes file, for example, in case I write that to a file. And this is a snippet on how it looks. So it has this JSON format of tags and data, and the coordinates, of course, within the geometry type polygon. And I can import it as any import format. It has the elements request, so I can see what are the things that I can import from it. And the default is use the geographics map, the same that will be done if I just run this in a standalone way. Okay, it seems I need to. Well, it's not working network right now. And then I can get the data itself from this GeoJSON. And in that case, I get the polygon back from that geometry. Okay. Now talking about the tiles. All the maps as background use tiles. And in general, we are handling the conventional tiles of 256 pixels by 256 pixels. And well, in general, they are split that way because in that way we can have many zooms, many zoom levels, and have more and more precise maps. And of course, if I go to, this is for zoom 2, 3, 4, I will add, if I want to draw the entire map, eventually millions of tiles. But that allows me to zoom in a map. Our main and default tile set comes from OpenStreetMap, but we have our own tiles server. So what we did was we have all the OpenStreetMap data, and we are building our tiles ourselves. So in that way, we can have our own style, our own layers, etc. In general, the zooms available are from 1 to 18. And you can access these tiles using the StreetMap no labels, and StreetMap labels only. In general, on each zoom, we add more and more detail. So not only more resolution, but also more detail. So for example, capital cities might appear at zoom 4, all roads at zoom 5, countries start appearing early in zoom 3. And we can also compute, for example, the size of a pixel in each zoom. So that we could say that 1 pixel in zoom 1 corresponds to 78 kilometers. That will be at equator, of course, while zoom 18 will be less than 1 meter. So that's quite a zoom. And for example, I can have a manipulate of all these layers. For example, if I don't want labels, let's see if the network is not working. Okay. And then I can access all these layers from, yeah, that's working, for the different zooms. Of course, there is not much in the tower without any label. It's very slow. Yep.
Is there a way to cache data on your Wolfram installation?
So right now, everything that is related with the entity value is using its own framework for caching. And for the tiles, we are doing a session caching only. So right now, it's within the same session, you will have faster maps if you already have computed that. But we are not exposing any way to have a persistent cache. And that's also because, I'm going to show later, we allow also access to all different servers, for example, and some of them, they don't allow you to have a long-term cache, for example. For example, we have a service that only allows you 1 hour cache. Our tiles are, the cache we use is of, I think, one day. So if you keep your session for more than 1 day, well, it saves some of the tiles. But
so the slipping map tiles that you're making, do we use Mapbox or something as the underlying server to generate them? Or
no, we are using our own server.
Oh, okay.
We have our own server for the tiles. We are using the OpenStreetMap data, which is the same one, for example, used by Mapbox. So we are using the same data, but with our own tile generation. So we have our own engine to generate all the tiles. Okay, yes, this is a bit slow, the network, but we might keep moving. Yes, the idea is that the servers will be in the same collocation as Wolfram Alpha. So we might access them in there. And then all the, oh, yes, it's having some network issues. Okay, and we not only have stream map data, but also satellite data. And we have also satellite data for other bodies, not only for the Earth, but now we have for the Moon, Mars, Mercury, and Pluto. And the plan is to add more and more data for all the planets, all the moons, etc. Yeah?
So this data is Wolfram you acquire from where?
Which one, the previous maps? Or
Yeah, Earth data.
all this stream map data is really OpenStreetMap data, but we are generating the tiles itself. So OpenStreetMap data is free to use, but the tiles are ours. That's right.
So I'm asking that because you were showing Chimborazo. I'm from Ecuador, by the way.
Yes, I know.
We're interested in doing some studies on the passage that different volcanoes near to the capital city about large flows. But I was wondering how accurate those maps are, because we need.
I will talk a bit more. I will talk about, more about the elevation data later. So, yeah. So, okay, I have to hurry, I think. Well, this is an increasing zoom for each of these satellite maps. Of course, we don't have the same zoom level for every map. And with our own satellite data, we have only up to 11 for the Earth. For the Moon, we have up to 9, up to 8, etc. for each of these bodies. We might access also external servers from GeoGraphics. So with the GeoServer option, we might specify other servers, for example, this topo map or statement, which has different styles, different data, etc. So that's possible. And we have added something new in the latest version of Wolfram language, which is an external tile service, which is Data Globe is the backend for this. And this is still in a experimental testing period, which means that we are not charging anything for this, but we are limiting the access to only 3,000 tiles per month per user. We need access to the cloud to request the data, the satellite images. And we might have a better and very improved resolution, up to 18 for satellite image. They also provide other layers, like a streetmap layer. They are building also using OpenStreetMap data, so it's going to be the same, but with a different style. Another more stylized layer, and a different layers also for satellite data, too. And we might have, for example, the same place and have a nice view of, for example, of the London Tower at zoom 18. So this allows a very improved satellite resolution imagery.
But 18 is the highest, regardless of which server you use.
No. I think if the service provides more zoom, you might use that as an option. So if you connect to another external GeoServer and it has zoom 30, you might use that. It will work. So, yeah. Then about the entities. We have plenty entities coming from Wolfram Alpha with position. But not all the entities has this position value. I have here a table with the number of entities and the number of entities with that position value set. In some cases it's the same, not in others. And well, some few examples. For example, if I want to see do a histogram of all the nuclear explosions that we have in the system, and we have, for example, using the entity value and the entity class of the latest nuclear explosions, we can see that all of them are from North Korea, so no one else is now doing that. Also, we can have geoentities again with weather stations, for example, for Fiji. It's very nice that we even spot islands that are even smaller than the points. And about entities with polygons, we have all these domains that have a polygon, but not all of them have the polygon set. For example, in one case that we want to improve more, is still ongoing, city data, that only has a few with polygon. Other cases have everything set. And for example, I can draw the polygon of an ocean, the polygon of, well, some cities like Moscow, or historical countries, like, for example, Aragon Kingdom from middle 15. And something else that we were missing in country data for many, many years, and we are adding, this is still not on production, but it's ongoing, it's the addition of some countries that are considered as part of the ISO standard, but that we were missing because they are really dependencies from other countries. But in some data sets, external data sets, you have, for example, reference to them. So we need to have them also in the system. So we are adding them now. It's probably going to be in the next release of Wolfram Alpha. And these are the different maps, the principal area and the default map area for these island countries in general, or island dependencies. Also, there are other types of backgrounds, which are the outline backgrounds, like, for example, coastlines, country borders, which allow me to have, oh, it was deleted. Let's see if it works. Well, country borders, which allow me to move, for example, to change the projection without any distortion of the map. Or dated country borders, for example, the one we saw for Aragon Kingdom. The network was somehow slow.
Is there a resolution option for those country borders? Can you zoom in very close,
Not now, really. We have a standard resolution that is like, if we put the map in a complete screen, it will look more or less nice. That's the idea of our current resolution. So we can have the history of the borders of the countries in different centuries. And to end very quickly, we have added a lot of high resolution elevation image. Now it's up to zoom 12. It means that every pixel will be around 32 meters around the equator. For example, this is for Lima. This is there is an avenue here to go down to the beach, and we can have different views. And here is the actual satellite image. We can extract different facts from the elevation. And we have added also elevation for different bodies in the solar system. So for the Earth, for Moon, for Mars, for Mercury, and Pluto, with different zoom levels. In the case of Pluto, we don't have data for all the values because, well, it's very far, so there is only one mission that tried to gather that data. And we might, for example, place solar system things in these maps in the satellite and compare them with the elevation map. And well, I'm really out of time, so thanks for hearing. And well, you are invited to. Oh. question? Well, okay.
I was wondering what's the limitation right now for them in your accuracy, their goal to meet the technical problem, licensing problem, data size problem?
To which of the data sets? To elevation?
Yeah, the resolution. Yeah.
Well, that's more a data issue. So because we want to cover all the Earth, so we don't have access to. There is no a data set that covers in the resolution we want all the Earth. So there are some specific, for example, for US you have like 15 and we need to mix these data sets. So that yeah.
So you have an entity called nuclear explosion.
Yes.
What about if I want to create my own entities? Let's say wars between countries in Latin America.
Well, we already have military conflicts, but if you want to your own and
Sorry.
yes, no,
I want to create my own entity.
yes. That's something covered by Tony in his talk. That is about the entity store. So there is now a way. Yes, entity store is the process.
The question was from consumer, like, can you add your own data there and process those images?
Yes. Indeed, with the entity store and with all the new mechanisms, you can interact your own data with Wolfram data and with all these functions for geographical plotting and stuff. Yes.
Sorry, entity store is already working for now.
Yes, there is a version of entity store already working.
And this has to be some kind of GIF format, right?
Right, to comply with the polygons we have with the same format, of course, yes. And there are some functions to import, export all that data. Okay, last one, I think.
What do you recommend using shape files or Geo Data format? What's easier in mathematics?
That's a tricky question. Well, GeoJSON is really a new addition, and we are trying to make it also efficient, and that's, but it's just the first version of this, so we are still working on that. Shapefile is an old format that it was already supported, but somehow I think GeoJSON, for example, supports all these bounding box that didn't have the shapefiles, and so depends on what's your actual application, I think. Okay, well, thanks for hearing. Now I invite you to the next talk from Jose that is also related with all this geocomputation. Thanks.